Hello, it's Dr. Harris, and there's one additional topic related to binomial random variables that I wanted to discuss uh, somewhat quickly, and that is the notion or determining the formulas for expected value and standard deviation when you have a binomial random variable. So, under the assumption that x is binomial with n trials and probability of success p, it turns out that the formula for expected value that we saw in the previous chapter reduces down to an extremely nice short formula. The expected value of a binomial random variable is simply the product of the number of trials and the probability of success in a single trial. So the expected value is n times p. And the standard deviation also reduces down to something pretty tractable. I'm not going to try to derive how it is. This is the case, but it turns out that the formula reduces to the square root of n times p times the quantity 1 minus p. Now, if p is the probability of success, 1 minus p is the probability of failure. And so the standard deviation of a binomial random variable is the square root of the product of the number of trials, the probability of success, and the probability of failure. Let's see that in an example. If we flip a fair coin 100 times, that was the situation where n was 100 and p was 0.5, then the expected number of heads is 100 times 0.5 or 50. And that makes a whole lot of intuitive sense, I think. If you flip a coin 100 times, you would expect half of them to be heads and half of them to be tails. And so half of 100 is indeed 50. The standard deviation is going to be the square root of 100 times 0.5 times 1 minus 0.5. And 1 minus 0.5 is also 0.5. So we've got the square root of 100 times 1 half times 1 half. 100 times 1 half times 1 half is 25. The square root of 25 is 5. And so standard deviation is going to be 5. So when you flip a fair coin 100 times, you would expect to get around 50 heads. And remember, the standard deviation tells us the range on which we expect typical values to occur. And so we would expect to be within 5 of 50. So between 45 or 55 is what we would expect to have. And if you go back and think about what the probability was in the previous slideshow of getting between 45 and 55 heads, it wasn't exactly 2/3, but it was not too far away from 2/3, which is what we expect typical values, the likelihood of typical values to occur within one standard deviation. So this is a quick application of expected value and standard deviation for a binomial random variable. I'm going to be asking you to look at computing the mean and standard deviation for z, the number of times that you would roll a 6 or lower in 16 rolls of a pair of dice. And so you try to apply these formulas to that scenario, and we will talk about that when we get together.